In today's video, I would explore a process in which multiple invocations of a REST API can be done in parallel using a data page. Now, in PEGA, there are various definitions of parallelism. So, the ones most often used are the concepts of technical parallelism and business parallelism. Now, if you go to PDN, you would find that there are pages in the PEGA Academy where you have these definitions of split join, or for example, adding a parallel process in a stage, or split for each, or spin off. Now, these are actually called something to do with business parallelism. Now, that effectively means that if you, for example, have a stage, or let's say an instance of a flow where you need to have two different things done in parallel to each other, then what you do is you kind of have, let's say, two, you have one assignment, then you split it off into two different assignments, and then you're sending it to two different people for approval. So imagine that you have a credit approval that needs to happen in conjunction with the manager approval. So what you can then do is you can then split it off in two different flows, and you can send them together to two different people. But that does not mean that, let's say, a manager and credit check person can actually work on the case at the same time. Of course, there are ways to handle it. You can actually use optimistic locking to handle it. But the idea is that even then, you're not using, let's say, different resources within a single time frame to handle them. What effectively happens is they are still working in sequence, but you can actually achieve business parallelism by sending it to two different people at the same time, and then you can manage that. But what I'm trying to do is something called technical parallelism. So what is the use case for it? So imagine you have, let's say a customer list, and you have, let's say, 5 customers, and you need to get the customer details of those 5 customers into your application. Now the problem is these customers, customer 1, 2, 3, 4, 5, are completely independent of each other, right? Now, if they're independent of each other, then you should be able to, let's say, call an API and get the information out of them independently. So let's say customer 1, I call an API, customer 2, I call another API, like that. But the problem right now is there is no like a very straightforward way in PEGA in which you can handle this in a way that, let's say, you call customer 1, customer 2, customer 3, customer 4, and customer 5 all in parallel, which means that they are using the same 30-second or 35-second time window. And once all of these calls are made, then you, for example, reconcile them somehow and then show it on the screen. Now, what will happen is, imagine that you have a PEGA API call. The PEGA API call takes, let's say, 2 seconds. Now, if you have 5 customers and you're calling them in sequence, what happens is those 5 calls will then take 2 into 5, 10 seconds. But if you can call them, for example, in parallel somehow, then what will happen is that will take much less time. Probably, let's say, at least it will save around 7 to 8 seconds, and perhaps can finish within only 2 seconds, because all of them are being called in parallel. Maybe it will take around 3 seconds. Now, that kind of technical parallelism is currently not very apparent within PEGA. So we will try doing something like that using data page. Now, the data page option that I have used is perhaps one of the most apparent ones, and that can be actually achieved using a data page. But the limitation of my process is that, so if you have, for example, 4 or 5 different APIs and you need to call them in parallel, then all of them need to have a data page attached to it. But if you want to do it somehow apart from data page, then you have to figure it out. And if you find another way of doing this, let me know. Okay. Before we proceed further, we need to frame a proper use case first. Now, why is the use case very important? Because if you don't form a proper use case before proceeding, then you will not be able to even find out whether the parallel processing is working. So you need to have a scenario where you can actually see the parallel processing working correctly. Okay. Now, for that, the first thing that you need is a REST API, right? Now, I could have, for example, created a separate application and then, created a service REST and then use that here. But I found that to be a bit cumbersome. So what I can do is I've actually gone into this website called Universal Tutorial. And Universal Tutorial actually gives me a list of countries and a list of states for that country. So what I have done is I have just registered myself and I've got an authorization token. And using that, what I can do is I have got a REST API, a free REST API. which is of course accessible from my PEGA environment. And I can, for example, search with any country here. As you can see, I can search with India, for example, and it will show me all the list of states for India. So the idea, so how have I framed the use case? It's as follows. Let's try it out. I will open the screen and I will create a case which I have already done before. So on this screen, these are something else I have done before, but this screen I've actually added a section where I've called it called show parallel API calls, and I've given a list of countries. Now this countries list is not really dynamic, it's simply static. I've added a prompt list in the property. So it actually gives me 4 or 5 country names, and that's about it. Now what I've done is I've also added a list of states for these countries. Okay, now the drop down, as you can see, is blank. So I actually made it in a way that it is not directly invoking a data page, because if I do that, it will automatically be called when the screen is being loaded. So I'm indirectly doing some gymnastics to actually make that work. But anyway, I will explain that. But the idea here is to show the parallel processing, right? Not to have a, let's say, not to have a proper application, like code, peer reviewed code. So what I'm currently trying to do here is simply to create a use case. So what I've done is I've given a list of countries here, okay? And what I'm doing is I'm having a list of like a drop down, empty drop down value. Now, when I click on this parallel API calls, the idea at the moment is it will then go through this list, call the API to get the states per country in parallel. So since I have 3 countries here, I can then, for example, make that call in sequence. So then, of course, if it, for example, one call takes about 1 second, it'll take 3-4 seconds. But the idea is if I call it in parallel, it will save time and effectively call it within one time period itself, and all of them will be called in parallel. So let's try it out and see how it works. So before we start showing the actual code in which this will be handled, let's try understanding the structure of the code. So let me just go to live UI and I'll just show you this part. So I have a section. This section is called show parallel API calls. I have created a row list, page list, and the row list, page list has some pre-populated values for the country. As you can see here, it actually has a property called country, and it's being directly loaded from the property. So I have a prompt list inside the country. It actually has these values. Yeah, no preferences given. And then of course you have the states of the country, and these states of the country is something that I would effectively load from the data page. So usually what happens, everyone knows that, normally you give the source directly here. But if I do that, as I mentioned before, it will then automatically load the data page if it finds any values here, or for example, if I change the value to something which is legible. So I don't want that. I want the actual triggering of the APIs to happen when I click on that button, not before that. So I have kept it as state list. Now the idea is when I have the API call response back, I will then populate the state list with that. Okay. Now these two are already configured, and I have a button. The button is what will actually make that invocation. So I've created an activity, again, not really the best way of doing it, but we can talk about that later. Now this is the most important part, is the activity. Now what I'm doing here is as follows. So first I am setting something called a pool ID. Now what is the pool ID? I would explain a bit later, but let's just imagine that for now as a random number in PEGA. Okay. Now I'm using that as the pool ID, and I'm generating a random number, and I'm setting it in a param.pool ID. Then what I'm doing is I'm actually looping through the list of countries. So as you see here, I have this 3 countries. They are part of a page list called row list. So I'm just looping through them. Okay. And then what I'm doing is I'm actually doing this load data page. Now load data page, what it does is it will then load the data page manually. Now before we do try anything like that, what I will do is I will simply show you what the data page does. So I have the data page. Data page simply takes one parameter called country, and then it actually gets the information back. Okay. And it actually shows it it stores is inside the PX results page list. So the idea is I will simply pass the country name and it will give me back a result list of states. So what I'm doing here is I am setting the country in a parameter. Again, this is not really required. You can directly use it, but I always have a proclivity of using parameters, so I tend to use that. So I have used the load data page functionality and I've used the d underscore gate states. Now, what happens with this is whenever you are using a pool ID, right? Whenever you're using a pool ID, PEGA then understands that this is something that needs to be run on a child thread. So you are currently working on a session which is also called a requester, right? Like a requester session. So you have logged in and you're working in a requester session. Now it actually runs on a Java thread, right? So if you, for example, add a pool ID, then PEGA understands that this needs to be run on a child thread, not your current thread on which your case is running. You are doing the clicks, everything. Okay, that's the first part. Okay, now, so what I'm doing here is, since I have now 3 countries and I'm actually looping through them, what will happen is it will be called in 3 separate child threads, right? As you can see, like all of them will be called in separate child threads. Now, once that happens, now what happens is now the actual invocation is going on in child threads, right? But once the invocation is done, how will the parent thread know that the child threads have finished working on the API call or whatever it is that is actually being called? So for that, what we need to do is use something called a connect wait. So when we do this and we use the pool ID, then PEGA will know that okay, all the child threads which are running with the same pool ID, then needs to be reconciled back into the parent thread. So as you can see here, I have not used different pool IDs for different child thread calls. I have actually given all of them the same pool ID. I'm of course sending I'm actually of course creating a random value for every invocation of the activity itself, but the rows themselves have one value, not each for row, but I mean it's like one pool ID for all of them, right? So you can see here what I'm doing is once this pool ID based invocation is done, then PEGA knows that okay, now it is being told to invoke the data pages on the child threads. Once that is done, so I'm using the connect wait because I know that okay, the API call will not take more than 5 seconds. I can actually make it I think less than 5 seconds also. I think it probably takes about 2 seconds, so I can make it 3 seconds as well. But what PEGA will then do is PEGA will wait 3 seconds and then reconcile all the child threads running with this pool ID, param.pool ID, and then put them back onto the parent thread on which you're working. Otherwise, what will happen is you will not be able to see the invocation of those records, or you'll not be able to access the clipboards and get the values out of these. Okay, once you get the value back, then the next part is simply to just set the value. So I have done some small some small things to actually handle it. So I have had a row list and then I added a loop inside it and then getting the values directly in here. Okay, that's how it is done. So that is the activity which is doing the invocation. So once you understand how the activity works, the actual execution of it is fairly simple. See how it works. So as I have shown before, I have 3 country names, and what I'm going to do now is I'm just going to populate the list of states for these countries, okay, by clicking on the button. Let's open Tracer just to make it a bit more easier to understand what exactly is happening on the background. Now, one thing which is important to note is I have gone to the settings and check this event type called ADP load. How I will and what exactly does that shows you, we will see. Okay, so what that means I'll also should tell you. So what I'm right now doing is I'm about to click the parallel API calls button. So when I click on it, let's see what happens. As you can see, all the 3 drop down values have been uploaded. So you can see it here. I'll just come back to the tracer a bit later, but let me just finish showing the drop down values. So you have all the values here. Okay, now what exactly happens right on the code level? So let's go back to the code and just go through that line by line. So first step is, if you look at the property set 1, what happens is I'm setting a pool ID. The pool ID value, as you can see, it's a random 5-digit number. Okay, it can be 10-digit as well. You can choose whatever you want, right? After that, what actually is happening is I'm doing the load data page. So that is the reason why this ADP queued for load is required. So ADP load means asynchronous data pages. So this method of I mean, like, pushing the execution of a data page into a child thread is actually called asynchronous data pages. So yeah, so I'm using asynchronous data pages to make this work. So as you can see here, when I click on this load, I mean, as the load data page happens, the DP queued for load page comes up, and it actually goes into the child thread. Same for the second thread, same for the third thread, right? Now what happens is, after this, when the third step actually comes in, and when the connect wait happens, all the reconciliation of all the child threads happen, and it's automatically present for the parent thread to ask for it whenever required. So as you can see here, once the connect wait is finishes, here, for example, on this invoke parent, I mean, I'm actually using this page 4.1. I'll go back to the activity. I'm actually using the d underscore get states, right? So what happens is, whenever this is actually being called, the loaded asynchronously page comes up and actually loads the value asynchronously. Now what that means, of course, is that, okay, had, for example, I loaded the entire thing in sequence on that 4.1, you would have seen the entire execution of the activity under the data page. But you only see the call. Why? Because, and you also see it says data instance found and data page instance is fresh, which means that this thread already has a fresh instance of d underscore get states for country India. So that is the reason why it automatically loads it. So it's already loaded, which means that it is not taking up a period of time within the current execution session, right? So as you can see here, once that is done, the code is actually automatically loading it, and on the tracer you can see it's just setting the values properly. So that's about it, and that is how you I mean, like, that is how you can now call, for example, APIs in parallel using asynchronous data pages. Now there are certain caveats here, of course, because not always can you do this, of course, because if you, for example, have, let's say, dependent APIs. So what happens, for example, you have 20 APIs to call, but some of them depend upon, let's say, the first API being called, and then you're using the output of that second API and then calling this next API like that. If you have a sequence like that, then you, of course, can't use parallel invocation, because then the child threads don't talk to each other, right? So whatever information you're passing it, that is all is going to be used. So ideally what you should do is, if you have, let's say, truly parallel API requirements, as I mentioned, for example, if you have 2 or 3 customers and you want to get the customer details using, let's say, multiple API calls, so then what you can do is you can have one data page, and that data page can simply take one customer ID and then can call, for example, 4 or 5 APIs underneath it. And then once the 4 or 5 executions are done, then you will get a page back. And then once the connect wait calls, then you can always see all the information. But again, the child requester API calls needs to be only done when you actually have a requirement for parallel API calls. Two last very important points. Let's go back to the activity. Your scope of the data page also matters. So as you can see here, I have used the scope as thread, which means that if you have a thread level data page, you need to use the connect wait on the same thread as the data page. Otherwise, the asynchronous execution will not happen. Similarly, if you have a requester level scope, then the connect wait needs to happen in the same requester as the data page, as a load data page. Otherwise, the asynchronous execution will not happen. Number one. Number two is, if you don't use, suppose you use, for example, a load data page, and you somehow forget to use connect wait, okay, then if you, for example, are referencing this page, imagine what will happen, for example, if I comment this out. Now if you, for example, call this, what will happen is PEGA will not understand that this d underscore get states was actually called on a child thread, because you have not used a connect wait. So what will happen is PEGA will again execute it afresh without even bothering about any child thread execution of that data page. It effectively becomes an orphan until the connect wait is done with the same pool ID. Until that is done, it is not accessible. So I think that is so that was about it. I showed you how to do in parallel invocation of REST APIs. I've also used it myself in multiple places. It works just fine. If you find any other way of doing the same feature but not using data pages, or if you find some other ways of doing it, again, you of course can do it using Java. I know that there are certain Java functions which you can use to actually, let's say, call activities asynchronously. But if you, for example, find some out of the box features which can be used to call APIs or activities asynchronously and in parallel to each other, do let me know. Again, when I mean parallel, I mean technical parallelism and not business parallelism. PEGA has enough of that. So thank you for watching my video. Hope to talk to you again very soon. Bye.